Today we're going to learn how to construct some two-column proofs. So the lesson objective is I can construct two-column proofs for congruent triangles and justify each step. So our triangle congruence theorems are SSS, and that stands for side, side, side. SAS stands for side, angle, side. ASA stands for angle, side, angle. And AAA stands for angle, angle, side. So note that S is for side, A is for angle, and there are 4 different theorems that prove congruence, and they must be in that order. So now we're going to talk about the reflexive property. So reflexive property means that something is congruent to itself. So triangle ABC is congruent to triangle ABC. And then we have the symmetric property, which means that if triangle ABC is congruent to triangle DEF, then triangle DEF is congruent to triangle ABC. So that's the same thing as saying 2 plus 3 equals 5 and 3 plus 2 equals 5. You just switch the 2 around. The transitive property is if triangle ABC is congruent to triangle DEF and triangle DEF is congruent to triangle GHI, then triangle ABC is congruent to triangle GHI. So there again, you have something congruent to a middle term. The middle term is congruent to the last term, which means that the first 2 are congruent. So in other words, if A equals B and B equals C, then A equals C. Another term to note is CPCTC. That means corresponding parts of congruent triangles are congruent. So I'm going to say that one more time. Corresponding parts of congruent triangles are congruent. If you know 2 triangles are congruent, then all of their corresponding parts are congruent. So if I told you that triangles ABC and triangle DEF are congruent, then you would know that each of those angles and sides will also be congruent. So this is our first 2-column proof. You guys probably haven't seen these, so follow along closely here. Here we have triangle PNQ. We have this point Y. And it's telling us that NQ is congruent to PQ. So you can see the little tick marks there. And then we also know that NY is congruent to PY. So my first step in my proof is going to be to write my given statements. So I'm going to write NQ is congruent to PQ. And how do I know that? Because it was given. So I can write given as my reason. And note that this is a side. So a side is congruent to another side. And then I also know that NY is congruent to segment PY. And again, I know that by given. And that's also a side again. Now, I don't have any more givens, but I'm trying to prove triangle NYQ is congruent to triangle PYQ. And in that, I want to use one of my triangle congruence theorems. So what do I know about this side right here? This side is in both triangles, and it's congruent to itself. So I can write QY is congruent to QY. And how do I know that? Think back to your properties that we talked about at the beginning. We know that by the reflexive property, because something is congruent to itself is the reflexive property. And again, that's another side. So I have 3 sides, so I know that my triangles NYQ and triangle PYQ are congruent by side, side, side. So there we constructed our first proof. Hopefully you start to get the hang of some of these, but we'll do a few more for practice. So here we have that RQ is congruent to TS. Is parallel to TS, sorry. These symbols are hard to see. So RQ is parallel to TS. So I'm going to write that as my first statement. And that's by given. And then I also know that RQ is congruent to TS. So I'm going to write that next. So I'm going to start out by writing my givens. And here I have my first side. Then I also know, what about this side? Think back to our last proof. I know that RT is congruent to RT by what property? The reflexive property. And then since these lines are parallel to each other, what can you note? Think back to Unit 2 and our stations. If I look at this transversal and these two angles right here, what do I know about those two angles? They have to be congruent because here I have angle QRT is congruent to angle STR. And I know that by alternate interior angles. So note here, RT was a side, and then we have angles. Now, it's not necessarily going to be in this order going down, so we need to look and see which ones we have. So we have a side, and then we have an angle, and then we have a side. So, therefore, we know that triangle, make sure you're lining these up, so triangle QRT is congruent to triangle STR, lining up the corresponding parts by side, angle, side. Another proof, we are given that angle ATR is congruent to angle STR. So angle ATR is congruent to angle STR. And that's by given, and this is an angle. So I'm going to mark that on my picture. ATR is congruent to STR. And then I also know that segment AT is congruent to segment ST, and that's also given, and that's a side. And then I know that the measure of angle QRT is congruent to the measure of, hang on. Then note I have this side. So I know that segment TR is congruent to segment TR. And if something's congruent to itself, that's by the reflexive property. And that's another side. So then I know that triangle TAR is congruent to triangle TSR. And what order do I have? I have that AT is congruent to ST. So I have side, and then I have an angle, and then I have a side. So I have side, angle, side. But note that I was trying to prove that angle S is congruent to angle A. And so now we can think back. Angle S is congruent to angle A. If I know that my triangles are congruent, I know that my corresponding parts are congruent. So I can put my corresponding parts, CP, so corresponding parts of congruent triangles are congruent. So our last one here, we're given that AC is congruent to segment EC, and that's by given, and that's a side. And then it also says that C is the midpoint, and that's given, and that's not a side or an angle, so we're just going to use that. So C is the midpoint of BD. By definition of midpoint, we know that BC is congruent to CD. So we can say segment BC is congruent to segment DC by definition of midpoint. And note, this is a side. And then I know that these two angles are congruent because they're vertical angles. So you can say that angle ECD is congruent to angle ACB by vertical angles. And note that's an angle. So now I was given that AC was congruent to EC, and you can see that I have a side, an angle, and another side. So I can conclude that triangle ABC is congruent to triangle EDC by side, angle, side. Another one, we have given that segment CE, so I'm given that CE bisects angle BED. That's given. And so if we have CE bisecting this angle, what do we know about these two angles? They're going to be congruent. So later down, we're going to use that. But we also want to write angle BCE and equals angle ECD, which equals 90 degrees. So that's also given. I'm going to mark those. And if they're both 90, then they're congruent. What did we say? This bisector means that angle BEC is congruent to angle DEC by angle bisector. So here we had a angle, here we have an angle, and then note, what do we know about this side right here? When you see something sharing a side, you're always going to say that it's congruent to itself. So CE is congruent to CE. Being congruent to itself is by reflexive property. And so therefore, I have an angle, a side, and then an angle. And note how the side is between the two angles. So that does work. So I know that triangle ECB is congruent to triangle ECD by angle, side, angle. Thank you for listening, and hopefully that was helpful. Come in for questions. Thank you.